Hello, this is Irv Shapiro with MakeWithTech. Here at MakeWithTech, we teach people how to innovate, how to create, how to design, how to make things by using desktop technology. And today we're going to explode the envelope of possibilities. We're going to learn how to use innovative engineering grade materials, materials that were classically only used in advanced manufacturing on a 3D printer that sells for about $500. This is an Ender 3 Model S1 Pro, a bit different than the Model S1 that I reviewed a few weeks ago. So stay tuned and let's learn something together. If you're new to watching MakeWithTech videos, then I want to let you know that we're more than just a video channel on YouTube. We're also a discussion forum, a place you can come and share ideas and ask questions and post pictures of the things that you make at forum.makewithtech.com. We're a place you can go to search for the latest 3D models and customize them with a working 3D customizer at models.makewithtech.com. So please join our family, subscribe here on YouTube, give me a thumbs up because the YouTube algorithm really likes that, and share this video with everyone you know. So let's talk about advanced materials, but before we do that, let's talk about this Ender 3 S1 Pro. So the Ender 3 S1 sells for $379. And this printer sells for, I think, $499. So it's an $80 difference between the two printers. What do you get for the $80? Well, you get a fully enclosed case that has all of the metal components enclosed in plastic. I don't think that adds any particular value. Looks nice. I'm not sure that adds any value. You get a touchscreen LCD panel instead of an LCD panel with a knob. Now, the touchscreen doesn't add a lot, but the firmware is different. The firmware is clearly a next generation of firmware. That's a big plus. You get sort of a cute feature. Let me turn this printer on for a minute. You'll hear that it's relatively quiet. You'll notice here this light. Now, I thought that was just cute. In reality, I found it was very, very useful when I was printing. So that's a nice feature. But what you really get that's most important is an extruder that looks very similar, but is really quite different. First of all, the extruder itself has all metal parts, which allows it to generate increased force. That means it can handle a wider range of materials. The hot end is an all-metal hot end. There is no Teflon tube, no Bowden-style tube inside that could potentially give off fumes at high temperatures. It's an all-metal hot end. Now, it does ship with a standard brass nozzle. In fact, this is the brass nozzle, I don't know if you can see this, that it shipped with, that I've replaced on this printer with a hardened steel coated nozzle that I purchased from Micro Swiss. And let's see here, I purchased this nozzle for $20 on Amazon. And the reason is that in addition to printing engineering grade materials that were non-abrasive, I wanted to be able to print abrasive materials. Now, why is it this printer can print engineering grade materials? because the hot end on a standard Ender printer, most of them are similar, can go to about 230, 235 degrees safely. And part of the reason is there's that Teflon tube, a piece of Bowden tube inside the hot end. You can look at this picture here on the screen, and you'll see in the traditional hot end, the Bowden tube goes all the way down to the nozzle. And in the all-metal hot end, the Bowden tube stops pretty much at the top of the architecture, or the filament goes directly in, as it does in this printer. So this can print at 300 degrees. In addition, I've successfully used this print bed at 110 degrees Celsius. Now, originally, when people started releasing print beds that are like this, that have magnets on them. So this is a spring steel bed. This is actually not the one that came with the Creality. I'll explain why in a few moments. But this is a magnetic bed, and it did not release at high temperature because I ran this print bed up to 110 degrees Celsius. So what do you get for $80? You get an engineering grade hot end with all metal components. You get a light, you get a little nicer LCD panel. You get enhanced firmware for the higher temperatures and for the touch screen. So I think it's well worth the dollars. Let's put this in a different perspective. About 3 years ago, when I started with 3D printing, I bought a Prusa i3 MK3. It's still made today. It's now called the MK3. I think it's the S or the S Plus. Basically the same printer with some refinements along the way. Valuable refinements, but refinements. That printer, as a kit, sold for $750. And it took me a solid 5 to 6 hours to assemble it. Now, today, knowing more, maybe I could assemble it in 3 to 4 hours. But assembling a Prusa i3 MK3 style printer is hard work. Why? It comes with lots of little parts, because Prusa's philosophy with that printer was to 3D print as much as possible. This printer comes 90% assembled. The base is assembled, the print bed is assembled. You basically take this rail, you screw it into the base, you screw the extruder on with 3 or 4 screws, you put the filament rack on the top, and you're done. You know, it's like 10, 15 minutes. It's really easy. At $750 compared to $500, and 5 hours of assembly compared to 15 minutes of assembly, this printer is just not only a better value, but the printer I would choose today. What's as interesting is the Prusa fully assembled is $1,000. So this printer is half the price of the Prusa. And as far as I could tell in my tests over the last couple of weeks, it can do everything the Prusa can do. So let's talk about those things. Well, the first thing I do when I get a new printer is I produce some prints. And often the first things I print are things on the SD card. There are these little tiny prints on the SD card. These are printed in MatterHacker Build PLA. We're using all filaments I purchased from MatterHacker today. Important note, I did not pay for this printer. This printer was provided to me by PeerGear, an Amazon distributor, at no cost. But I did pay for all the filament I'm using here today. And these sample prints are great. They look the same as the prints off the Ender 3 S1. So then I wanted to knock it up a level. So I printed this print. Now this is a little more technically challenging of print. There's a little bit of stringing on this print in a couple different places. But the reason is I wanted to test the extruder. Now this test is very subjective, not very scientific. So what I did is I went into Cura and I increased the top print speed to 150 millimeters per second. Yeah, I know that doesn't actually flow all the way through. Many of the speeds for other areas, printing your walls, printing the first layer, printing the top layer, are formulaic. but things like acceleration and jerk, retraction, those all impact this printer. So, but I just wanted a coarse test. I also set the layer height to 0.3 millimeters, so you can see the layers very clearly on here. Why'd I do that? I wanted to try to force a lot of filament out of this extruder. So printing fast with larger layers requires more filament. It had no difficulty at all. Now I will note here that I compared the speed I got in the estimate from Cura to the real speed, and the speed I could print this on my Flsun Super Racer, and that's a great high-speed printer. The quality is not quite as good as the Ender series, but that printer is still a third faster than this Ender printer when I did this rough adjustment. So if I really fine-tune the profile, I think this could be 80% of the speed of my Super Racer, but a Delta style printer is still a faster printer because jerk and acceleration, many other parameters are just easier to optimize for speed. Now, one of the filaments I really like using is ColorFab XT. But ColorFab XT requires higher temperatures. And I have 13 printers here in the MakeWithTech lab, but only one of them, and it's not physically here, it's actually at my son's house now. My Prusa can print it over 235 degrees Celsius. And this ColorFab XT requires at least 240 degrees. I generally print it at 245 with the bed set to about 75 degrees. And the reason I like it is it produces these beautiful translucent prints. Now, I printed that on the PEI print bed that comes with this S1. This is an enhanced print bed on the S1 Pro versus the S1. And most people say you shouldn't print PETG, and ColorFab XT is a PETG type of filament on these because they stick too well. So what I did is I put a liberal amount of Dimafix on top as a release agent. Most of the time you use Dimafix as an adhesive. The purpose I was using it was as a release agent. It worked perfectly. This stuck without any problem. Now, let me show you how beautiful this print is by turning off the lights here in the studio and putting a light on under here. So, Alexa, turn off the studio lights.
Okay.
Isn't that pretty? Now you'll see here, this is a little base I bought online for about 20 bucks. It's an LED base and it changes colors. Alexa, turn on the studio lights. So this was a very, very successful print. I would not have been able to print on a different printer. Now, after printing this beautiful print, I decided it was time to do some engineering related things I could think about the strength of the material. And so I decided to print some carabiners. Now, these carabiners and these crystals are both OpenSCAD models. Now, the crystals come from a really interesting organization called Code and Make. Darren over at Code and Make produces wonderful SCAD models that you can use with the customizer, the OpenSCAD customizer. Now, to do that, you download the code for the model, you install OpenSCAD. That's a lot of work for folks. And it used to be a couple years ago, you could use a customizer on Thingiverse. That's been broken for a long time. So I went ahead and I built an online customizer that anybody can use for free at models.makewithtech.com. So if you want to print these crystals, go to models.makewithtech.com and type in the number. I'll put it up on the screen and put it in the description, 484-2466, into the search bar for Thingiverse and click search, and this model will come up. And then you can change the sizes, the dimensions, the number of crystals on your build. Now you can do the same thing with the carabiner. The carabiner is 57174. Just go to models.makewithtech.com, type in 57174, and these actually are designed to be smaller. I wanted them bigger so I could sort of test them. So first, I printed one in PLA. This is a silk PLA, which is why it's that beautiful color. And it's quite strong, but I feel it's starting to give as I pull it. And it's very clear that if I squeeze it like this, it's going to crack. Now, that's a characteristic of PLA. PLA is relatively strong, but it's brittle. So what could I print it in that would be as strong or stronger, but not brittle? I could print it in nylon. And nylon is equally strong. I cannot break this. And you can see here that you can push in on the sides. It's not going to break. It's going to bend. That's why they make things like seat belts out of nylon. It's both flexible and strong. Well, there's a wonderful nylon that you can purchase at MatterHackers, which is Talman 3D Nylon 230. And I purchased it in the natural color. That's this color here. And it's one of the easier nylons to print with. So I printed this right on the PEI sheet, the standard bed that came with the Ender 3S1 Pro. I did use a liberal amount of Dimifix, and I had to heat up the heat bed to 100 degrees Celsius. Now that's another thing you can't necessarily do on every consumer grade printer. Another plus for the S1 Pro. And that produced a wonderful, wonderful product. Now, I wanted to do something even more extreme. Nylon-X is a filament from MatterHackers that is nylon reinforced with carbon fiber. Now, there are other manufacturers that make a carbon fiber reinforced nylon. I'm just a big fan of the quality I get from MatterHackers. I bought this filament. They did not provide it to me for free. Now, this stuff, though, is a little bit pricey. Nylon-X was $58 for half a kilogram of filament. To put that in perspective, PLA, the Build PLA from MatterHackers, is $20 for a full kilogram reel, a full reel. The Nylon 230, the Talman Nylon 230, is $45 for a full reel. So this nylon, the nylon is basically twice the price of PLA, and Nylon-X is 2x again. So why would you use it? Well, because it is a true engineering grade material. First of all, when you feel it, it's a little bit rough. It doesn't feel like just regular plastic. It is strong like nylon, but much stiffer like PLA, except you're not going to break it. Now, one of the reasons I printed all these, and I'm going to print a lot more of them, is I ordered a stress meter, a digital stress meter, digital force strain meter, and I'm going to be in a future video, I'm going to be doing an actual test to show you exactly how strong these different materials are, so you can determine whether to print in PLA, in PETG, in nylon, or in Nylon-X. But there's a problem with Nylon-X. And in fact, there's a problem with all nylon. Nylon absorbs moisture. That's why even here you'll see these in these fancy bags. Now, these bags are actually really useful, and I happen to buy them from Amazon, from the Sun brand, who also makes filament. But it's interesting. This is one of the things you go online, you look for, and you'll see 5 different manufacturers have the box that looks identical for every manufacturer with a different name here. So these were 20 bucks for 20 bags. And what this comes with is both the bags and this little vacuum pump that works remarkably well to take the air out of the bag. So when you're not using this filament, you need to store it in a place where it will not absorb moisture. Now, the humidity here in my shop is about 37, 38%, which is not terrible. When I go to the southern coast in the United States to visit my son, the humidity there is 80 or 90%. But that still would be enough to cause a problem. So I print directly out of a print dryer. Now, this is a print dryer from eBose. I have two different print dryers from eBose. The eBose print dryers were provided to me at no cost by eBose. And the way this works is you put your filament inside, you plug it in, and it blows hot air through here. Now, when I'm using one of these print dryers, the inside humidity in these print dryers is about 19–18%. Sometimes it gets even a little lower. So generally, I leave the filament in here for a few hours before I'm going to use it to make sure it's good and dry, and then I print right out of it. Now, this eBose single size print dryer did a really good job of drying the filament, of getting the humidity down quickly. Much better than the dual filament dryer that I also have. But there was a problem. When I put a reel in here and then I fed the filament out, for some reason the way the reel interacted with the hub in the middle, it didn't turn real smoothly. And that might have been the Talman reel specifically, but it didn't turn smoothly. So I switched to using the 2-reel filament driver instead of the single reel driver for the prints that you see here. So I would dry the filament, print with it from the filament driver, and then store it in one of these bags. Now there's another challenge with Nylon-X. Because it's abrasive, if you leave your standard brass nozzle in your printer, it's going to ruin it. You need to replace it with a hardened steel or potentially a ruby nozzle, some type of hardened nozzle. I used the Micro Swiss hardened steel nozzle, which was $20 on Amazon, but I actually used a tool from Olsen Ruby that they make for their ruby nozzle. And it's a torque wrench to make sure you tighten that nozzle just the right amount. Now it comes with a 7mm socket, which is the right size for the hardened nozzle, but the original nozzle in the printer required a 6mm socket. So you just switch the socket. Now the other thing you need to do, and I'll show you some pictures here, when you go to unscrew that nozzle, you have to hold the heating element on your printer so it doesn't turn. Now, some people use these big wrenches. You can buy these online. I really like using a Robo Grip from Rigid. I find it's just the right size. On the side of that heat block, you'll see there are two wires. There's a set of wires for the heating element and a set of wires for the thermistor, basically the thermometer inside the heating block. You want to make sure you don't break those. And to get to the nozzle, I actually took the fan and the bed leveling sensor off to make it easier to get to that. I'll show you a picture of how I set that up to make it easy to replace. So I replaced the nozzle. When you replace a nozzle, you re-level the bed, and I went to print. And I did a whole bunch of different prints, and they didn't stick to the bed. Basically, the first layer would print really well, and after a couple layers, it would come loose and start moving around, and then my print would fail. So I tried a lot of different things. I tried using the regular print surface with a variety of different adhesives, including 2 different brands of glue stick. That didn't work. I tried switching to a Creality glass bed, both the smooth side with glue stick and the rough side. That didn't work. I even tried a sheet of Garolite. Now, I'm not actually sure this is Garolite. I bought this online. Garolite's in short supply right now during the supply shortage, and I really wanted to buy the MatterHacker Garolite made for printing nylon, but they're out of stock of it. So I tried this Garolite. I tried roughing it up with sandpaper, putting glue stick on it, all the things you're supposed to do. That didn't work. And then I tried something called Gecko Tech because people have recommended it. It didn't work. So you might be asking, how did I successfully print this? Well, I went back to an old trick from my early days of 3D printing when print beds weren't very good. I took a spring steel sheet, just a generic one, not the one from Creality, and I put blue painter's tape on it. Yep, regular old-fashioned 3M brand, and I think the brand matters here, 3M brand blue painter's tape. Then I put some purple glue stick on it. I heated the bed to 70 degrees Celsius. I printed the filament at, let me check my notes here to make sure I get this correct, at 255 degrees Celsius. The bed was actually at 75 degrees Celsius. Perfect. It stuck to the bed. It didn't move at all. And when I let it fully dry, it was still stuck a little bit. So I had to take a single edge razor blade and get out of under a corner a little bit and pry it up, and then use a paint scraper to get it up just a little. But it wasn't bad, and it wasn't bad enough to even damage the painter's tape. Now you see here I'm rubbing the painter's tape. Never do that. You're getting oil from your fingers all over that painter's tape. That's a bad thing. So put the painter's tape down, don't touch it, put the glue stick on it, heat your bed to about 75 C. That's all you need to do. Now, once MatterHackers has their Garolite back in stock, I'm going to try that because painter's tape is messy to use. It takes a little bit of extra time. So what did we learn today? We learned that this S1 Pro can handle any of the engineering grade materials I threw at it. It prints PLA. It prints PETG, specifically high temperature PETG, the ColorFab XT. It prints nylon beautifully right on the regular bed, at least the Talman nylon. And it prints carbon fiber reinforced nylon using blue tape and a little bit of glue stick. Well, folks, I hope you learned something today. If you want to print these models, head over to models.makewithtech.com and put in the model numbers of those individual models. If you want to discuss this, you can leave comments below, or you can go to forum.makewithtech.com. And as always, thank you for watching. Please subscribe, click on the bell, all of that stuff, and let's continue to learn things together.